Hey, welcome to the Explainer. Have you ever looked at a really slick, modern app and just wondered, how on earth did they build that? Well, you're in exactly the right place. Today, we're basically putting on our virtual hard hats to explore the .NET ecosystem, starting from its concrete foundation all the way up to the actual code that makes it all tick. So yeah, how do developers put together these incredibly complex, powerful applications so fast? The secret isn't some kind of magic. It's all about having a solid plan and a really powerful set of tools. For a ton of developers, that's .NET. And like any great project, it all starts with the foundation. All right, part one, the .NET architecture. Think of this as our foundation. This is the solid bedrock that makes everything else we're going to talk about even possible. See, it all works in layers. Way up at the top, you've got your application. That's the code that you actually write. But here's the thing. That code doesn't just talk directly to your computer's operating system. Nope. It relies on the layers underneath it. First, there's this massive library of pre-built code. And then, under that, there's a super powerful engine called the Common Language Runtime, or CLR for short. And that engine, the CLR, it's like having this tireless, automated construction crew working for you 24/7. It handles all the tedious stuff, like managing memory so you don't have to worry about it. It checks for safety issues before they can cause a disaster, and it handles unexpected problems gracefully. It's doing all the heavy lifting in the background, which frees you up to focus on the creative part, the actual design of your app. But let's be clear, the .NET we have today is not the same one from 20 years ago. Not even close. It started out as a Windows-only tool. Then, with the shift to .NET Core and now modern .NET, it completely transformed. I mean, it went open source, it got way faster, and maybe most importantly, it became cross-platform. This was a seismic shift. It means the apps you build can now run almost anywhere, and the skills you learn aren't locked into just one operating system. Okay, part two, programming styles. So, the foundation is poured. Now it's time to look at the blueprints, the different ways you can actually design how your app is going to work. So one approach is something called visual programming. The best way to think about this is like digital Legos. Instead of writing every single thing out as text, you build your user interface by literally dragging and dropping components. If you've ever moved a button onto a form in a design tool, well, that's exactly it. You're building by seeing. So what's the trade-off here? Well, visual programming is definitely easier to get started with. It's just more intuitive, but you're kind of limited by the components you're given. On the other hand, pure text-based coding has a steeper learning curve, for sure, but it gives you total, absolute control over everything. The key isn't that one is better, it's about picking the right tool for the specific job you're trying to do. Now, another key blueprint is event-driven programming. And honestly, most modern apps work this way. Instead of running like a movie from start to finish, the application kind of acts like a security guard on duty. It just waits. It sits there and listens for something to happen. A button click, a new message, a mouse movement, and only then does it spring into action to handle that one specific thing. And that's the whole flow. The application is just listening in this constant loop. An event happens, let's say you click a button, that click triggers a very specific piece of code, which we call a handler. The handler runs, does its job, and as soon as it's finished, the app goes right back to listening. This whole listen, react, listen cycle is what makes modern software feel so incredibly responsive. Okay, part three, rad tools. We've got the foundation, we've got the blueprints. Now let's open up the toolbox and find our power assists that help us build really fast. First up, the heavyweight champion, Visual Studio. This is your all-in-one, everything but the kitchen sink workshop. It's the full integrated development environment, or IDE, and it's famous for its world-class debugger and its smart code completion that sometimes feels like it's reading your mind. This is really the choice for developers who want every possible tool integrated into one single powerful package. But what if you prefer something more minimalist? A custom-built toolkit? Well, that's Visual Studio Code. It starts out as a super fast, clean, simple editor, but then you supercharge it with the exact extensions that you want. It's the go-to for developers who really value speed, flexibility, and crafting their own perfect environment from the ground up. And then there's JetBrains Writer, the specialist. This is a cross-platform IDE that is just obsessed with code quality and productivity. It's legendary for its refactoring tools, which help you intelligently clean up and improve your code with just a few clicks. Developers often pick Writer when raw productivity and code craftsmanship are their absolute top priorities.
Part 4. Code constructs. All right, let's zoom all the way in. We're getting down to the individual bricks and mortar, the essential building blocks of the code itself.
So let's start with two basic blocks, structs and enums. A struct is like a custom little box that you create to hold different but related pieces of information. For example, a point that holds both an X and a Y value. An enum is much simpler. It's more like a custom label. So instead of using a random number, like 3, you can use a much more readable name, like status.completed. And if we dig just a little deeper, you can really see their different philosophies. A struct is a true data container. It can even have its own functions attached to it. An enum, on the other hand, is much more restricted, and that's on purpose. It's really just a friendly name for a number. Knowing when to use a simple label versus a more complex box is a huge part of writing clean, professional code. So you've got all these different building blocks. You've got numbers, text, your custom structs. How do you make them all work together? The answer is type conversion. Just think of it like translation. Sometimes the computer can translate between types automatically, but other times you have to be really explicit and tell it, hey, I know this looks like a decimal, but I want you to treat it like a whole number. That's called casting, and it's an absolutely essential skill for connecting all the different pieces of your code. So there you have it. We've gone on a really quick journey from that solid architectural foundation to the design blueprints, to the power tools, and finally down to the very bricks of code itself. It all works together to create this incredibly powerful and flexible ecosystem. And that leaves just one question. With a foundation this strong and tools this fast, what are you going to build next?